Hello everyone, I am Anusha BM from Sri Venkateswara College of Engineering, Bangalore from ECE department. Now I am going to give small presentation about nanomaterials. Introduction about nanomaterials. A nanomaterial refers to a material with at least one of its dimension in nanoscale. A size of a nanomaterial varies from a nanometer to 100 nanometers. A nanometer nm is a 1 billionth of a meter 10 to 9 meter. A nanometer is approximately the length equivalent to 10 hydrogen or 5 silicon atom agnated in a line. Nanotechnology has become a interdisciplinary science involving chemistry, physics, material science, and biology and medicine. Nanotechnology is the study of all the phenomena and process involved in the synthesis, properties, and applications of nanostructure and nanomaterials. Any nanomaterials of nano size with its properties distinctly different from its book from considered as a nanomaterials. Every nanomaterial has three-dimensional structures of nano size. They are classified into 0, 1 and 2-dimensional materials. Nanoparticles, nanocluster and nanocrystals are called zero-dimensional. Nanowires, nanotubes are the one-dimensional and nanofilms are the two-dimensionals. Size dependent properties. Surface area. Many physical and chemical properties of a material depend on its surface properties. If a bulk material is subdivided into individual nanomaterials, the total volume remains the same, but the collective surface area is greatly increased. Example, the collective surface area of cube each side 1 meter is 6 meters square. If this cube is progressively cut into smaller and smaller cubes, the surface area will increase to 6,000 kilometers square. Those surface area is immensely increased on moving from bulk to nanoscale. Properties like catalytic activity, gas absorption and chemical reactivity depends on the surface area. Therefore, nanomaterials can show surface related properties that are not observed in bulk. For example, gold nanoparticles greater than 20 nanometer is purple color. Gold nanoparticles 10 to 20 nanometer is red color. Catalytic properties. The catalytic property of a material depends on particle size. If the size of the particles reduces from bulk to nanoscale, surface area increases. This leads to very high catalytic activity of the same material. Example, bulk gold is catalytically inactive, but the gold nanoparticles are catalytically very active for sensitive redox reaction. Conducting properties. Nanomaterial shows different conducting properties like electrical conductivity, thermal conductivity and photoconductivity, etc. Electrical conductivity. The electrical bonds in bulk material are contains due to overlapping of orbits of a billions of atoms, but in nanoparticles very few atoms or molecules are present so that electric bonds become separate, discrete, and the separation between different electric state varies with the size of nanomaterial. And some metals which are good conductor in bulk become semiconductors and insulators as their size is decreased to nano levels. Thermal conductivity. As the size of a material decreases, to nanoscale, their melting point decreases because surface atoms are in contact with only few atoms in nanomaterials and require lesser energy to overcome intermolecular forces. Example, 3 nanometer CDSC nanocrystal metals at 700 K compared to bulk CDSC at 1678 kilo per hour. Synthesis of nanoparticles. There are many techniques available to synthesize nanoparticles, which can be generally grouped as top bottom and bottom up approaches. In top down approaches, bigger materials are broken down into small nano size materials by means of various physical methods, but these approaches are limitation like these methods requires expensive operative. These methods cause crystal grouping damage and introduce surface defects, internal stress in rusting nanomaterial. Methods of synthesis of nanoparticles. There are classified into three types: physical, biological, and chemical. Physical, electrochemical, ultra solution, laser adultation, interdation, evolution, and conduction. Biological is classified green synthesis. Green synthesis classified into two types: plants and microorganisms. Plants classified into four types: leaf, root, flower, and fruit. Microorganism classified into four types: fungi, bacteria, algae, waste. Chemical: etching, mechanical milling, laser alteration, separating, thermal decomposition. In bottom-up approaches, desired nanomaterials are built from the bottom by orbital assembly of a growth species like atoms, molecules, ions. This approach has advantages like the methods are simple, versatile, and available valuable. Method provided better control over chemical composition, size, moisture, and accept ratio of nanomaterials. Nanomaterials with less defects and high purity were synthesized. Thank you.